All right, we are live.
Live on YouTube.
Yeah.
Yeah.
Hi everyone, I am really excited today to host John Porral, who is currently a residential architect and computational designer based in Madrid. And if you follow John on Twitter and Instagram, he has amazing GIFs on how he used code to automate residential design and architectural aspects. So I thought it would be great to know his journey and what's his thought process of making this kind of automation. And I personally feel it would be quite insightful, and we can use like some of this aspect and take inspiration in our design process. So thanks a lot, John, for your time to do this.
Oh, thank you. It's great to be here. Yeah, looking forward to it.
Yeah. So I would like to know, can you tell us about your background, like how you started, and out of all things you could do, why you chose architecture?
Oh, go on. Yeah, architecture. I don't know. I've always liked, making stuff and drawing and those sort of things. So that, I guess that's when you're 17 and 18 at school. I guess that's the classic. What do I want to do? Like, I guess architecture or whatever. And yeah, and then I guess I was also a bit of a geek. So the computers thing was always in the background. So I was always trying to learn new stuff there. So it's always felt very natural to me to design, and then at the same time learn a bit about computers and that sort of thing. Yeah.
Got it. And I saw like you have done a lot of projects and competition. And was it during your school time you started like doing coding, or it was at a point where you saw like there is inefficiency or frustration in the design process and you thought I should code?
Yeah, actually, I only learned about grasshopper. Like it didn't exist for me like for most of uni. I only learned about it like last year, so like 2013 or 12 or something like that. And I just thought it was like a cool tool, but I didn't really see the benefit. But once I was working in London, I went straight to London when I finished uni, and doing a lot of repetitive work. You're doing residential, and we're doing a lot of feasibility studies and that sort of thing. And there was a lot of repetition and changing small things to fit more stuff. And so there was a lot of repetitive work, like arduous tasks. I didn't feel a lot like design. It felt more like work, and and in the back of my head, I was like, I'm doing this a million times, time and time again. I'm sure I could do this with a computer. Like a computer could do this. So in the back of my head, I started thinking about it while I was. But still, I had nothing. I had to spend weeks of my life pushing beds around and pulling a little door this way or that way. It was a bit, yeah. But that's what sort of got me on the thing about coding. Yeah.
I see. And if I were to ask, like, what are some key highlights of your professional journey? Any particular project or thing you would like to share with us?
Yeah, I guess. I mean, what actually got me on this whole thing is rather than a single project, it was more the feasibility studies I was doing in 3D Read, which is the firm I used to work at. We're doing a lot of them, and feasibility studies. Lots of times you send them out and they never come back. So it felt like it was a lot of work, and I was a team of a couple of people doing a lot of work for us and while. So that's what got me thinking. So in the background, so when I got home from work, is when I started doing that sort of thing. So it wasn't a specific project. It's more like the fact that we're doing a lot of abortive work. Like we were spending weeks of time just, and then we threw it away.
I see. And like, is there any like role model or inspiration like architect you follow for your work?
Oh wow! In computation stuff, there's there's loads of people. Like I guess all the everyone. I think I started roaming on the grasshopper forums. So there's all the and I'm very much a lurker. Like I very rarely leave a comment. but I'm sort of there and reading. So all the classics, you know, you've got Andrew Human, you've got all the Daniel Piker, you know, all the people that do all that sort of thing. So I don't know. I mean, you know, David Rutten, obviously. I mean, he's sort of the guy behind everything. Yeah, but I mean, I guess now you start seeing people who are doing more specific things, like the stuff like that, sort of stuff that I'm doing. I don't know, like there's Finch, there's Test Fit, so all of those guys, I'm sort of, you know, keeping my eyes on them, seeing where they're going.
Yeah. I also follow like Andrew and Daniel's work a lot. Like also like this people initially they were like quite active on Grasshopper, and then now they are working on AEC startups and like also taking this features on like another level.
Yeah, exactly. Yeah. We'll get there. But no, I saw your interview with Andrew. Yeah, that was really cool.
Yeah. I wanted to know, like, so is there any particular like tutorials courses which you find quite useful for your coding learning process?
I mean, I got some terrible answers. I mean, my problem is my source of information is Google. Like at the beginning, you know, you start Googling, you know, Grasshopper, how to do whatever, and inevitably takes you to the forums, because the forums, you know, even the old forums are, you know, a source of amazing information even nowadays. And then the new forums are amazing, and you know, there's loads of great people there, and they've helped me a few times. But yeah, it's you know, it's that sort of thing at the beginning when you're just trying to figure out how to connect all the little cables. And then once you get your head around it, that you're actually coding, because at the beginning it just feels like you're plugging stuff in, but then actually it means like you're actually coding once you get down to it. Then you start Googling a bit more generic stuff. You remove the Grasshopper bit from the Google search, and you start looking into, oh, how would you do this in a math sense or a geometry sense generally? And then you start getting into Stack Overflow and all that, where people are really helpful, and you try to convert that into Grasshopper code, and then that's a whole other universe. But yeah.
Got it. Yeah, I could totally relate to that thought process. And John, now we would like to get into the technical and demo aspect of the interview. So if you'd like to share some of your work and thought process behind those works.
Yeah, sure. Maybe I was thinking I could show you well, how I got to, like, step by step, because it's actually been a process, like where I got to where I have now. I think this, I'm clicking on the right button. Oh, can you see on my screen?
Yeah, it's.
Here we go. Can you see that?
It's in the process, so like it's a black screen right now, so maybe it might take a while.
Yeah, I haven't used Zoom like throughout the pandemic, and I haven't. I'm more of a Google Meet, so I'm a bit lost. Is it there yet?
Maybe my screen got frozen. I think it's still like a black screen, but I can also double check on YouTube if I can see that.
Maybe it went to a different desktop. Maybe if I put it in this desktop. No. If I drop stuff here, like, no.
Maybe if you can stop and reshare a particular screen.
And how do I stop? This is terrible. I got a border around my screen, but I don't know how to.
It's the same share screen button, like there would be stop screen at the bottom.
It's weird, yeah, but no, the Zoom meeting has actually gone. It's pretty bad. No, sorry. Yeah, the Zoom icon is gone.
Oh.
So I can't find the meeting again. That's true. Do you mind if I restart the whole thing? I know that's not great for
Yeah, you can rejoin the meeting, like whatever you think
Yeah.
is yeah
So,
works.
I'll force quit out of this and see.
Mhm.
Let's see. That's fun. Oh no. And I don't.
Is it frozen from your side?
I know I'm using the computer. It's oh, here we go. Okay, I found it on the task manager. Okay, I'll kill it and come back.
Okay, see you soon. Meanwhile, Join is coming by. As you can see some of his work on Instagram.
Cool. Here we go. Ah, you're showing that. Cool. Can you hear me now?
I can hear you.
Yeah. So I don't know what happened there, but I'll try and share my screen again. Maybe if I. There you go. Ah, this is different
I
to what
can
happened.
see now.
Yeah,
Yay!
perfect. Oh god. Okay, yeah, that was not great. Where was I? Oh no, but I'm not sharing.
I see like a PDF.
Yeah. So this PDF was my life for a couple of years in London. It's the London Housing Design Guide, and I know it's not very cool to talk about code, but this is basically what I was doing day in and day out in London. It's very strict. Basically, you have to comply with certain areas and dimensions, and for each room, you have to have a particular set of furniture, which is, I mean, I thought was incredible. Like you have to have specific space for specific sizes of furniture. Obviously, then people put whatever furniture they want in, but you have to prove that this particular set, which they tell you here, this catalog of stuff, you have to comply. So for me, this was a system. Like if you always have to comply with this, like they're giving you such strict rules, there's very little margin for design and stuff. So you just had to make sure everything fit. And in real life, in Revit, which is what we used, every little change, this wall moving that way 50 millimeters or that this way, whatever, on the door, moving a bit, meant, you had to push the bed and then push the wardrobe and then check on the adjacent apartment if that still worked. It was a lot of work. And so what I thought was, I can solve this. I can make an algorithm which puts furniture into a room, and I can just because you can tell there's conflicts between the code. Like if you get closer to the wall than this, then this triggers, and otherwise that triggers. So I thought this is a solution landscape. I can see how there'll be areas of types of rooms where the code is trying to push you in. And I thought, well, I just have to see what this looks like. So what I did was I made this. Well, this is on my website. Basically, I pre-calculated 60,000 rooms, L-shaped rooms, so they all have like a little kink out of them, but they're also rectangles because then the kink is nothing. And it took, I think, 3 months to calculate, every variation. But then I had like a pre-calculated set of rooms where I can just push stuff around, and it would tell you this is the layout that would come out. But crucially, what was important to me was, is this a good layout? Because you can put the furniture in, but is it actually working, and is it legal? Based on the London Design Code. So I put in the next step in the algorithm, which is to rate the result. and that's what you can see here. That's the little 3. So this based on a 3 out of 10 isn't a very good layout. And if you click on this, it tells you why. It tells you, you're too close to the wall on this side and too close to the wall on that side. So you lose lots of points there. Otherwise, there's lots of really good things with this bedroom, but those things just take you out. And then so for me that was really cool, because then that tells you, I can click on this, and there's it just finds the closest bedroom that's similar, the most similar bedroom that's actually legal, and this one has a 7, and that's great. And you just click the button and it tells you that this one is fine, and you click on this and it tells you everything's green, so everything's working. But then what I wanted to see though was the solution landscape, like see how the different bits of code conflicted with each other, like so how the rule about the bed clashes with the rule about the wardrobe, or the door distance to the wall, etc. So I put all the points, all the 60,000 bedrooms onto this sort of map, which is really basically the solution landscape, where every pixel is a room layout. The color is the orientation of the door. So red, for example, is with the door facing outwards, and green and blue is with the door facing inwards, but on opposite hands. And what was interesting to me is that, that you could see sort of, ribbons of areas which were legal or not legal, but were possible, where you could put rooms in. And then it was an area of black where it was just impossible, and the computer just, you couldn't put a room there. And then the brightness of the pixel is the goodness, the score that I was talking about of the room. So you can see that only like very few rooms are actually compliant, and this told me, and obviously, and red is largely the most legal, because when the door opens outwards, it's easier for the stuff that's inside to fit more comfortably. But then this is it was interesting to me. You could click here on this, and then it zooms in and shows you the room, and and you're in this layout, which isn't compliant because it's very dark on the graph, and right next to it there's one that's even worse, or this one has a bug actually. Ignore that one. This one, for example, is really uncompliant, is really dark, and this one's even worse. I'm guessing because of the distances to the walls, etc. But right here is perfectly legal, like and it's just because the door moved a bit. And this to me was interesting, because in architecture it's such a chaotic system that something is completely illegal, you can't build it, it's a terrible bedroom, and 20 centimeters away or less, you're fine. That's great. Go ahead. And to me, that's interesting, because if the computer understands that, and he's able to move in the solution landscape towards the good solutions, you could basically let it design itself. And that was the first version of what is now the algorithm that's on my Instagram, which was this L-shaped stuff. Maybe now I can show you. Can you see my right now?
Yeah, I see.
Yeah, perfect. So then I submitted my proposal for the Venice Biennale, which is currently exhibited, and they had accepted it before I had it ready, which was awful, and then I had to code really quickly for a long period of time, and it was terrible. I should have prepared better, but it's what happened. So basically, I had to turn that algorithm which did L shapes into any sort of shape, and I had to interact with people in the Biennale, because it's an interactive thing where people can draw any sort of shape, and the algorithm just furnishes it for you. But basically, this is the massive monster that is the algorithm, and it's essentially a couple of loops connecting all the different options together. But maybe I could sort of, you can see here, this is a curve I've drawn in Rhino, and the algorithm, if it just updated, will update the room, and obviously I can tweak it up and down, so it's faster, it's slower. So at the moment, I think it's done it quite quickly, but I can make it take up to 20 minutes per solution, and it tries down to the millimeters, just testing every possible solution. So here you go. That's what it's found. But I think what's cool is if I take you around the script and to show you, there's a lot of stuff that's interacting with the clients, so the people that are drawing on the Biennale. So is largely based around receiving information. You receive I think it's a CSV file from the website, which is actually like the front end, and then receiving it and converting it into a curve. And then from then on, it gives it to the algorithm that the furniture. So most of this that you see here is that it's receiving that you receive a curve and you have to calculate it, and it's going to be a bedroom, or this is short circuited. It's usually connected to something, but to be able to show you and for it to work, I put this in. So that I'm forcing it to be a bedroom basically, but it could be a bathroom or a living. And then from there on, it takes it to here to the dashboard, which is where you can set the resolution of the solution, like how many solutions do you keep per loop. So basically, it's trying to, it tries lots of options, and then I'm limiting it to, for example, if you put, I don't know, actually 200 beds, for example, bed positions, and I'm forcing it at the end of the loop just to keep 50. Because as it's a tree that sort of grows at every loop, it sometimes gets crazy. But so if you want it to be a bit performant, you have to limit it there. Obviously, if I could just turn it all the way up and it just tries everything, and it takes loads of time. But from there on, I call it the curve normalization because in the Biennale, people can just draw any shape and it's going to be terrible, and and it'll be tiny or it'll be huge. And that would affect the experience a lot because people, might think, it's not their fault that they didn't know it had to be a specific size. So I'm just grabbing whatever curve they've given me and I'm just tweaking it a bit just so it's, the right size and has, and isn't too crazy with too many points around it, because the more complex it is, the harder it is to put a layout in. I do a couple of sanity checks, which is, I don't know, for example, if the whole room, for example, is super narrow, for a start, like the bed is never going to fit there. Like there's no way, like straight off the bat, that it's ever going to work. So this would kill it initially and not let it keep going. And there's a few things here about putting the room elements is what I call the stuff that would be fixed in a room. So doors and windows, essentially. And then furniture is self-explanatory. And this is grabbing geometry from this Rhino file and just basically grabbing it and making it ready to place onto the room, which I'm getting to. And here we go. So this is where the loop starts. It's an anemone loop, where basically each loop, it loops once for each furniture you place. So loop 0 would be the bed, loop 1 would be the wardrobe, etc., etc. And what it's doing is, I'll show you actually. So I'll short circuit it so it actually doesn't loop the 4 times it wants to loop, or the 4 objects of furniture, but actually just does the first. Actually, this is going to do 2, so the 0 counts. So it's going to do the bed and then it's going to do the wardrobe. There we go. And basically, what it does, it's coming in through here and it's putting the bed in loads of locations, and it grabs the bed by different places, because initially I had it by the midpoint, that it just grabbed the bed and put it loads of places, but then it didn't quite touch walls, and you want it to be lined up to exact locations and walls and stuff. So I'm grabbing it by the edges and grabbing it by the middle and just placing it loads of times onto the room. It's basically quite brute force-ish, but it's the way you get good results. So here you can see this one is showing the wardrobe because it's the last one it just tried. And you can see it's tried all these different locations. And these are the ones that don't clash with the walls, basically, because it's tried loads. But you can see that's, it's trying lots of useless stuff. So I'm just filtering, keeping only the ones that are working until, and this is just checking about leftover space, because every time I put something onto a wall, I have to remove that bit of wall from the next loop because I don't want to try, if the bed's on a specific location on the wall, I don't want the wardrobe to even trying to go there because that'd be pointless. So I'm trimming that bit of wall out, and then that's why I feed into the next loop. And then I just keep removing bit by bit. But what I really like are these diagrams that come out. This is the data tree that gets produced. So you can see it's a data tree that where the first branch is every position of the bed, and the next is branching out for every position of a consecutive objects of furniture. So, I mean, I'll throw it with all the other stuff, all the rest of the furniture now. But basically, you can see like these are all the positions of beds which are valid, and then it tried putting wardrobes there, and you can see, for example, this position of the bed didn't have any valid wardrobe position, so it just kills the data tree that option right there, and then it doesn't propagate into the next objects of furniture, which is trying to speed it up a little bit. There's no point in trying stuff that's already not work. So if I'm now giving it all the furniture to loop through, I really like how the tree, keeps expanding because it starts branching and it looks pretty cool. Takes a second there to calculate. Here you go. And here you go. And you can see here, like each, and this last one I think would be like the smallest one. I think this little chest of drawers. So you can see how it's going down through the all the options and keeping only the ones that are good, and then it gives you this result, which actually, I mean, you can see here, all of these. If you get basically to the outside ring, it means you're a valid solution. Like it's possible to fit you in. The problem is now how which one is the best one, because I could turn this on, which is all the information, and it's crazy. There's loads of different combinations, and I don't know which one's actually good or which one's best, because technically they all fit, but maybe some of them don't work because they're too close to the wall or whatever. So from this point on is the subjective evaluation, because before now it was objective in the sense that it's just trying loads of stuff, and as long as it's not colliding into a wall, you're good. From then on is when I start looking into the quality of the solution, and basically, well, there's a number of criteria I'm following. Each of these is one of them, so 4. And basically, when I do these, I then do like a sort of score weighting, which I'm personally evaluating what's more important than what, and that's why it's subjective, because that's me doing the what I think is a good solution. So that's the subjective side. But for example, this involves trying all the ellipses, because you need in the I should have said before, in the London Housing Design Guide, aside from the furniture, you have to fit activity zones, is what they call them. It's the classic circle that you draw that you prove that there's a bit of space to move around in a room. So this is just a little bit of script which just tries to fit an ellipse into the space, and if you can fit an ellipse, you're fine because you're compliant. And my subjective thing is if you can fit more ellipses, you're better. You get a bit more score up to a limit, but yeah, you get a good result. And then the rest of it is distances between objects of furniture. I think if I turn this on, yeah, you get. I'm measuring between the bed and the wardrobe, etc. Am I far enough? There's a space to walk through, etc. And then these, I think, are similar things: space in front of the furniture and inaccessible areas of room. So, if a bed is suddenly cutting off a bit of the room and it's impossible to walk through, this will detect it and give it a really bad score. So it goes through here, and then that gives me these are all the scores coming out, and that sorts all the results and tells me that this one is the best one based on what I've told it. It's really bad because it's only getting, the best one is getting at 2.7, so it's terrible, and then you can probably see why. There's this not a lot of space in front of the wardrobes, etc. Or between the bed and the desk. But basically, this is what is found. and it would get better results if I'd allowed it to try a bit more different results, but I didn't. So here you can just scroll through all the different options, going down in quality. You can see it's going down in score. So basically, yeah, just shows you what it's found and just sorted it, but telling you this one is really the best one. And then from here on, it's all, exporting back to the website, all that sort of thing, logging it. There's a log that logs all the activity and all of that, and saving the files into SVGs. There's a lot of stuff that isn't related to doing the layout. But yeah, I mean, that's essentially like the grand scale of things, how this works.
John, I am super impressed. Like, this is incredible work. Like, I really like the whole thought process and the interactivity part. So I have a few follow-up questions. So first is, if I understand it right, so like, is there like a hierarchy of furniture elements in the for loop? So you start with a door and then a bed and then the next furniture, and like it starts with the edge of that furniture size and it places on over the whole shape, and then what, like there are like 20, let's say 20 different possible positions for bed, and then in second round it starts with like a table furniture, and then it goes like what places it doesn't intersect and what are, like as we showed in that chart.
Yeah. So that's something I worried about, like the orders things, like, I mean, because maybe I was biasing it towards a particular type of layout if I was doing always the beds first, for example. At the moment, it is based on order of size, so it goes bed, wardrobe, etc., down to the chest. But my thinking was for the 60,000 bedroom layout, because I cranked it up all the way to the top. It was taking 20 minutes per solution. I was trying everything basically. So if it was so comprehensive that it would find, the bias would sort of be dead by the fact that it's just trying so many things, that there's no way to find other solutions that you hadn't found already, because it was just trying everything. I do want to test it to see if it found different results if I like flip the order, for example. But I haven't really gone down that route yet.
Yeah, but like, yeah, I think logically it makes a lot of sense to start with a bed. And do you like, how do you place, what's the logic for the doors? Is it start with the corners of the polygon, like polyline, or
yeah,
it also?
Okay. So I'm treating the door and the windows, which aren't shown in here, differently, because to me that's what the architect feeds in, right? You design the shape of the room, place the door, that's fixed, that's what you're giving the computer. I place the window, and then the computer is what then places the rest of the furniture and tells you what a good layout is. So essentially, my answer to your question is that's up to the architect, basically. So yeah, I could give it freedom to start testing positions of doors, but in reality, you're not gonna. That's not something that the computer would choose to put the door on the opposite place of the room, and then it would still work. So that for me, that the door is a static thing.
Yeah, and like I see, because many times it's defined by the corridor, and you have only like limited positions for the door.
Yeah, exactly.
So, and for the evaluation, you said like you have like a loop which runs like how many ellipses it can fit. So it's like more like the logic is like a good enough space between all the furniture and shows a better quality of the whole design layout.
Yeah, so that's something that's very typical. Like, I mean, I've seen it in Spanish regulations and in London regulations. Obviously, it's just a requirement to prove that you have space around in the room left over, because you can make a room that's so tight that you can't walk around. So this is a space where, I guess, to get changed or to move around or whatever. So yeah, that's something that's additional that you have to prove that fits.
Right. And in the web interface you showed, so does it like call the grasshopper script, or it's the same algorithm you coded in like JavaScript or something?
You mean the bit that people draw in?
Yeah, like in the beginning you showed like that there was a website, a web page demo.
Ah, yeah. This one or the one before? This one.
Yeah, this one. So is this like a interactive demo or it's a recorded version?
Yeah, no. So this one, no. This one is actually all pre-recorded. This is the same rooms that are here, basically, like literally the same files. It's just I color them with a filter here, which I'm showing you here. So it's also pre-calculated because it's doing it live isn't quite ready yet. But
Yeah,
yeah, I
yeah,
mean, this is on my website. You can just go to my website and play with it yourself. Yeah.
for sure. Yeah, and I can only imagine like because it's gonna take compute, so like real time output makes sense.
Yeah.
And how did you create that visualization which you showed off like 60,000 color coded pixels?
Yeah. Yeah, that's when I went to Stack Overflow and had to start learning about multidimensional spaces and all that. Because like, to me, each of these layouts is I think it's a five dimensional point basically. Well, I mean, some of them are actual points, or actual geometric points. For example, where the kink happens. So those are 2 dimensions. Then the position of the door is another dimension. The flip of the door, and so which orientation it's facing. I think the radiator as well was another dimension. And then basically once you have that, you have basically a 5-dimensional point, right? So instead of having XYZ, it's got a couple extra dimensions, and I'm treating it as if there were points. Like this graph is called Cohonan map. I'm happy I remembered that because I forgot. But a Cohonan map is basically a way of flattening high dimensional space into, in this case, 2 dimensions, to represent, show a representation of the space, basically. So really, this space is actually in 5 dimensions, and you can't see it on the screen. So I flatten it so you can see it on 2. Yeah, basically that's
Yeah,
what's happening here.
yeah, because like the moment like you talked about, okay, if you move 1 pixel, it has lesser score, and then you move next, then the score increases. I think a lot of design like intuitions or like takeaways can be developed from like such a comprehensive study, that what are like 1 or 2 small decisions you can make that can drastically improve the score of your layout.
Yeah, exactly. And that's what's sort of frustrating when you're working, right? Like you do a little change and you have to recheck everything because you might have completely screwed up the layout, like just by moving something 5 centimeters, and suddenly the I don't know, waste pipe doesn't comply, or the door suddenly is illegal. So this is what I think this is the subjective version or aspect of the algorithm is doing a lot of important work there.
And if I understand it correctly, the way it works is you have those 5 dimensions, and the score associated with is another parameter, and the room layout image is another thing. So you project that, and then the pixel intensity is driven by the score value. And
Yeah,
if you click on that pixel, then that image pops up.
exactly. Yeah. So yeah, it's basically a grid. Yeah, of all the spaces in this 2D flattened Cahonan map, and yeah, when you click on it, it generates the URL for the picture based on the coordinates where you've clicked on, and then it goes and finds that image and puts it on the screen. And I haven't done this before, by the way, but this shows you like on that pixel, these are the same room but different orientations of door.
I did like a similar dimensionality reduction, like for one machine learning algorithm, like for style gain. So I had like a data set of all the flow plans, and using like principal component analysis, like it it did like a 2D projection where like all the similar looking layouts were clustered together. So, yeah,
Yeah,
I'll definitely check into this
yeah,
algorithm.
that's actually because I met the well the coder that did the Cohonan map plugin for Grasshopper, and yeah, I mean, and John Harding, who I met when I was working 3D Read, and he told me about this, and at the moment, obviously, I didn't understand anything, but sort of stayed in the back of my mind, and when I needed it, suddenly it popped up. Um, and yeah, I think it's related to sort of neural networks and that sort of thing. I haven't really gone down that route personally myself, but I think I think it's sort of related. I think.
I see. Yeah, but I really like the process. Like, and is this like I'm curious to know,
Mm-hmm.
were there like any beta versions for this? You tried out different things that didn't work out as per your plan, and then ultimately you ended up this solution.
Yeah, yeah. There was a lot of testing, and you try different things and weird stuff, and Grasshopper. Well, not Grasshopper, but generally when you're coding, like you try the good versions of layouts, and you're like, oh, it's working, and suddenly I don't know, a curve flips at some point in the script, and suddenly it's the wrong way around, and the furniture on the outside of the room, and you don't know what's happened, and then this monster of code, you have to find the problem, and it's a so rather than a beta, it's more like this is the result of patching on patching on putting fixing until eventually it works sort of reliably, um, just through sheer you know throwing energy at it until I cried basically.
Yeah, like because uh, I can only imagine like once the script gets bigger, and if you have a lot of
Mm-hmm.
dependency, like the computation time in Grasshopper like also increases a lot, and you have like
Yeah,
so many things talking to each other, dependent on each other. So I could like even for debugging, I could only imagine like it's gonna be
no,
like a
it's
very challenging.
yeah, no, this is definitely the wrong way to do things. I've learned since because obviously I've learned a lot while doing it, but basically you learn you have to maybe take the jump and do it in some other language. I'm trying what I'm trying to do now is actually do this whole thing again from scratch in JavaScript, um, and hopefully have something that works and does the same sort of thing. But obviously, be faster because everything is faster than Grasshopper. Um, and yeah, and basically, yeah, you take it out of this spaghetti language and have something that's a bit more, yeah.
Yeah, I just had a thought. So uh, I was I was looking into like currently there are a lot of like uh, companies putting out like coding in GPU, like
Okay.
parallel processing. Like so right now, if I'm not wrong, like this is like CPU based, like sequential operations of like uh, find different options for bedroom and then do
Mm-hmm.
another loop for. So there is in GPU you could do like parallel, so all the bed positions,
Yeah,
furniture position are computed parallelly. So I wonder like that might also reduce the compute time, and it
absolutely. No, yeah, that's something I should have in the back of my mind. Because yeah, when I did in JavaScript, I wanted to like be actually better and faster. So yeah, actually, so because you see like the tree that it generates, the data tree here. So obviously, like it's almost you can see the actual parallelness of it here, or the sequence of it. But so obviously, like you can't get to this one unless you go down this particular route, right? So that's literally something that has to be done in that order. But within that, so for to test each position of the bed if it collides with with the walls or other furniture objects, um, that those collisions where I'm testing like loads of collisions, basically it's loads of options. Yeah, I definitely want to do that with the GPU. It's here, I think. That's the one that's doing all the colliding. And that's the one that's doing a lot of the heavy lifting, and I ideally do that. GPU just a bit faster, hopefully.
Mm-hmm. Yeah, and I think like the one like couple of really good things which apart from automating the residential code I found quite interesting is the data tree structure you have and also the visualization on like the pixel. So it's not only like because many times in generative design like we produce a lot of different layouts and then we have like evaluating function like in either Galapagos or other operation where we find the optimal solution. But that visualization is different compared to what you have, and it's a lot of like the power of those visualization is like you could draw inferences and like conclusions pretty quickly you just from like first glance. So that is pretty great.
Yeah, thank you. I mean, I think visualization is important, right? It tells you the story very quickly about what's going on, and I like how the London design code, which is so bland and such a boring document. Like when you do this, the flattening of the 5 dimensions, all that stuff, it turns into this crazy looping because you can see that there's circles of areas of things which comply and don't and stuff. I think that's super cool. Like by mistake, there's a guy that wrote that a bed has to be 700 away from the wall, and suddenly that creates this sort of shape, and it's I think it's quite cool.
For sure. And last question on this aspect is like, what was the most challenging part about the whole grasshopper script? Was it like the logic of placement of furniture or evaluation or like just reading the London document code and codifying it?
I think actually we mentioned it already. It's I think debugging in Grasshopper is super painful because you have to sort of go through and test different things. Where does it break? Do I want this to happen? Do I not? Should I change this? And if you're scrolling through, going in and out. I mean, the reason I know my way around it so well is because I've sort of had to, really slowly go through every piece of code, trying to find, errors and bugs and all that sort of stuff. And why does anemone stop working? Why does whatever stop working? That took a lot of time. And personally, because I started this, like the original file started years ago. Personally, like I had to learn a lot while I was doing it. So for me, the data tree stuff is something I wasn't too sure about at the beginning. I knew sort of what was going on in the background if you're joining two lists together, what it's trying to do. But when you start doing it and you have to control or manage something that's branching out in lots of directions, and you want to cut the branches where you don't want them to go and that sort of thing, that took a lot of learning as well and careful work, because as soon as you do the data tree wrong, suddenly everything explodes. And it's that was part of it.
Got it. And so I remember, like you mentioned, you have few ideas for like future work on this. So is there any way like a person can test this out, or like
I mean, at the moment, it's nothing. I literally started, testing code, just doing collisions. I mean, it's nothing at the moment. I do want it to be online someday, and people just be this sort of API where you have a line in Revit or Rhino or whatever, and you click a button and it sends it out to my server somewhere, and it gives you the layout back. But that's I think a bit far in the future. I think I'm still now. I have to learn JavaScript and all that, and because I mean I know a bit. You see it on the website, that's all JavaScript. But actually making it a product or something, that's going to take a while.
I see. Yeah, I feel that like I'm also like in those areas where like prototyping something takes another time frame, but to make it to production level, it's whole another like procedure.
Yeah. I mean, I haven't got a clue. I don't know what I'm getting myself into. Like, you start to have to start, I don't know, billing people, I guess. I don't know. I don't know how to do that. Yeah. So there's a lot of learning that's gonna happen in my afternoons after work, basically.
Yeah. But I think like based on like the visualizations and the layouts it's producing, I think it's gonna save so many hours of like optimizing layout.
Yeah.
Yeah.
I mean, actually, that's interesting you say that, because obviously, the time wise, it's great because it does it so quickly. But because I've had this conversation with people, architects who are like appalled at the fact that this exists. You're like, you're removing, like, taking work out of architects' mouths, etc. To me, it's not about the speed. Like, I don't care if it was faster or slower. To me, it's about the checking and the fact that that it's a good layout and you don't have to worry about it, and the fact that it's comprehensive, and it's tested so many solutions that this is the best one. So to me, it's just to increase the quality of solutions. It's not about being more efficient or less efficient, and then charging X for for your services or whatever. Like, that's not what this is about.
Got it. Yeah, and also like the code document has so many things to cross check, so it's better to have like a tool that does that and like manual check over on top of it.
Exactly. Yeah.
It
There's a
reduces.
company called Upcodes, I think, over there in the US, and they're doing that. I mean, I haven't really looked into, because obviously I know in the US it's not something I need to look at, but apparently that's exactly what they're trying to do, like something that checks your layout for you. Yeah.
Mm-hmm.
I think it's great.
Yeah, I was in recently a conference organized like in our university called AI for Design, and there was a talk from a from representative from Upcode. So it was quite interesting. Yeah.
Right. Yeah, cool. Is that online?
They are gonna share the videos soon, so it's not online
cool.
yet. Yeah, it just happened last week. Yeah.
I see. I'll keep my eyes out because that's interesting. Yeah. And obviously, like, my version of the code is nothing. There's like 4 rules. Just don't crash into a wall. Stay this distance away, etc. But once you get into that, that's a whole universe.
Yeah, but like I think this even shows that if you have like a good understanding of the code and the layout with few logic, you can create like so many different versions and also like good layout design. It doesn't require like a hardcore like optimization engines and algorithms. If you have like logic, you can create such tools.
Yeah, that's actually, like, that's what I think. I mean, I know there's a lot of push, and and everyone trying to do push the boundaries of what's happening, and everyone's doing neural networks and doing all this sort of deep learning and all that stuff. Like, this is pure, like, narrow intelligence. This algorithm does one thing and it just does it, which I think there's still space for that. Like, there's like doing this with neural networks would mean doing this algorithm to teach, to train the algorithm, which sort of defeats the point. If you have this algorithm to train the neural network, you might as well just use this algorithm. So to me, like, I'm still a fan of clicking around, and making sure that this narrow intelligence sort of works really well.
Yeah, like I think if it's like ultimately we try to identify the hidden like rules behind the layout generation in neural network, like in deep learning models. And but if we know directly the logic, we can code it rather than.
Yeah, exactly. Yeah, because you literally have the rules written down. You just need to put them onto code rather than paper for humans to read. Yeah, I think that's a great way to see it.
Yeah. And I have seen other like animations on your website as well. So if there is like, if you could provide overview about like your other works, that would be great.
So those, I mean, I started my Instagram. I don't know. Can you see more than just my rhino right now? Or or is
No,
it
no,
just?
no. It's just
Ah, I mean, I've got the stuff. I was just showing the video. Maybe I need to change my settings. Oh wait, I just realized. I could have turned my camera all this time. Well, you haven't missed anything. Just my face. Wait, I'm trying to find how to change my share screen. Anyway, yeah. So basically, on my Instagram, yeah, there's all of this. It's just variations on my Instagram. It doesn't let me. Here we go. Sorry, I'm terrible with this. Here we go. Can you see everything now?
mm,
Yeah.
I
Can you see the
see.
video?
Yeah, yeah. Now I see the video.
Yeah. So basically, I mean, this is the sort of thing that's on my Instagram. This is all just variations on the stuff you've seen already. Like this, I'll make a sequence of polylines basically, and just feed them in a loop to the algorithm I just showed you, and it just fills it in on every frame. You know, it's a solution, and I just put them all together and it sort of works. But it's always like I always try to give it a reason. Like this one's about flexibility, so it ties in with what we were saying about just the fact that it tests every option, and and you can see like as the bathroom moves, how the bedroom has to react. So the fact that one small change somewhere else changes things far away. So yeah, so my Instagram I sort of have little experiments on how the algorithm behaves basically.
So the way that worked is like in the same like grasshopper script, you have like a for loop which gradually moves the polygon, and then you capture that layout, and then you make.
Yeah, basically, I just it's a separate file. It's a save as where I have like an enemy loop outside of everything. So like there's a couple of loops in there already, but I just have something outside of that, and it just loops throughout the whole thing, and and it just calculates every frame of the sequence.
God. And
Yeah.
I I have seen like similar like layout configurator animations for Finch 3D. Do you feel like it's the same logic how they produce those animations
In 3D?
in Finch 3D, like in Finch?
Oh, Finch. Sorry. Yeah. I'm guessing it's similar. Yeah. There's a few videos I think on GIFs online about Finch, so I'm sort of waiting for it every time they release something because I want to see how if I could deduce something from it. But I'm guessing it's the same sort of logic. They got some really cool stuff, and I think they do the same thing except it's 3D groups rather than polylines. Yeah,
Got it.
I think. Yeah. Yeah. I mean, there's all the other stuff that's on Instagram. Yeah.
Yeah. I think like I'm quite like inspired by the whole logic, and it gives like also a takeaway that you can create like this amazing tools right in Grasshopper. You don't need to go in other programming languages to create some. If you have an idea, you could do like quick prototyping using this.
Yeah, no, absolutely. I mean, like when I started this, I knew nothing. Like I just didn't realize what I was getting myself into. And somehow it's accessible, so it sort of lures you in, grabs you. Yeah.
Right. Is there like anything you would like to suggest or advise to students or young professionals who want to do develop similar tools?
Yeah. No, I mean, I don't know. I mean, I guess I'm usually very oriented based on a project. So I'll have something I want to do, and then I'll figure out how to do it. So I would say to anyone that's trying to learn how Grasshopper works and that sort of thing, find something you want to code, like just and give it a try and see where it breaks, and try the Grasshopper forums. They're really good. I guess Yeah. I mean, that's essentially it. Like, what I mean is, as opposed to abstract learning, like start reading the Grasshopper Primer, page one, do. Because then that's going to take you nowhere. Like that's so abstract. Um, I personally am more like project driven. I have to have something I want to solve.
Got it.
Mm.
And is there anything you wish you did differently in your career?
uh, I don't know. Yeah, I mean, no. I mean, maybe it started sooner with the computer stuff. Like, no, I mean, I'm happy. I'm super happy right now. But maybe like the computer stuff, I didn't quite click in with me. Well, like I said before, like at uni, I only learned about this sort of thing at the end, and it's not because Grasshopper didn't exist. I'm not that old, but it's just that it didn't happen. Like in my uni, that it just didn't exist. Teachers didn't sort of push you in that direction. But yeah, basically, I mean, it'd be cool if I'd started a bit sooner. Maybe now I'd be at the Andrew Human level.
I see. And what's coming next for you? Like, and yeah, any other things if you have more time, you would like to pursue?
Well, I'm doing that thing that I'm trying to transfer all of this into JavaScript. But at the moment, everything's going really slowly. I don't know. Spain in the summer is just shuts down. There's nothing. You can't do anything. You have to see all the friends. Go to the swimming pools. It's terrible for my JavaScript. But yeah, basically, yeah. That's the sort of thing I'm working on now.
See, I have two fun questions to end the interview. The first uh, is there like any architecture city you would like to travel in future, or what's your favorite city?
Wow. Cities. I mean, I'm still really in love with London. That's I came back to Madrid, but London is there's so much stuff going on. It's great. Yeah, I don't know. I mean, obviously you want to travel everywhere, right, and see a bit of everything. But in terms of where I want to go, like I really love the Netherlands, like generally like the whole country. Yeah, yeah.
And like because of the culture and like a lot of activities, London is you like London?
Yeah, exactly. I mean, there's so much stuff going on and exhibitions all the time, and they're super interesting. And yeah, I mean, they had exhibitions on computational stuff where, either they had all the Gilles Retsin, I don't know, the chairs that additive. I don't know how you even call them, but they had an exhibition on that, and that's for me was like super, research stuff, and suddenly you had an exhibition. So there's London's like there on the edge of what's going on. Yeah, so that's what's interesting to me about it.
I see. And like any books or video or conference which made a big impact?
Yeah, I mean, I don't know if it's the one, like the one that straight went to my head is the Four Walls and a Roof, which I think is brilliant. I can't believe I've forgotten the name. but basically, yeah. So Four Walls on a Roof is brilliant, the book, and then there's a couple of lectures online, which is just great as well. God, I can't believe I forgot the name. Can't find it now. That wouldn't be the moment. But yeah, that's the one that comes to mind immediately. It's not computational. It's just about architecture, and it's so clear in what's in his thinking that I just really admired it.
Yeah, it is. All right. I think that's it from my side. Thanks a lot, John, for this amazing demo and like walking us through the whole logic and process. It really helps us to understand like how to develop similar tools and uh, how to create a better optimized layout design. So thanks a lot for sharing all the knowledge with us.
Yeah, no, thank you very much. I think it's very exciting. Hopefully, it wasn't too boring.
I really enjoyed each and every moment.
Great. No, great. Thank you very much.
Yeah. All right. Have a nice rest of your day, John.
Thank you, and you
Bye.
too. Now I need to learn how to hang up. Okay.
Bye.